Hey, hi everybody, we're gonna get started. Everyone can just take their seats and get ready for a night of soils. Yay! Okay, well, welcome everybody. Yeah, we're going to be talking all about soils today. We have two awesome speakers I'm super excited about. We're just going to give you a little introduction about who we are and what's going on. So my name is Maddie. I work for the Yurok Tribe Wildlife Department. I'm also a conservation filmmaker and photographer, and I run this event with my friend Alyssa.
Hi everyone, my name's Alyssa Owen. I'm one of the project managers with the Eel River Watershed Improvement Group. So first I just want to tell you a little bit about Earwig. So we're a local small nonprofit in the area. We primarily focus on doing in-stream restoration in the Eel River Basin as well as surrounding basins. We also do that by large wood structures, fish passage, improvement, revegetation, and invasive removals, as well as some educational outreach such as this event. We'd really appreciate any donations from you all tonight. This is put together by a small group of passionate team members, and we were just really run off of the donations for this event. So anything really helps, and we appreciate that. If you feel inclined to donate larger amounts, you get to join our membership team, which is super awesome and fun. There are rewards for it. We're also looking for any suggestions. We have a suggestion box up here for speakers, topics, or people you want to hear from. We'd be really interested to hear what the community is into. So if you think of anything, write it down, let us know. If you think of something after the event, you can also let us know on our website under the Educational Outreach tab. Sounds on tab, suggest a speaker/topic. So that would be great. Whoops, not too far.
Okay, I'm going to give a background on our speakers, who are both super awesome and are so knowledgeable, and I always learn a lot from my friend Kylie, who's going to speak tonight. So our first speaker we have is my friend Kylie. She is a research engineer by day and small-scale farmer. She tends land along the North Fork Elk River using regenerative earth practices focused on building biodiversity and healthy ecosystems above and below ground, growing nourishing foods, and raising happy and healthy animals. And then after Kylie speaks, we've got Susan Marshall, who is an emeritus professor of rangeland resources and wildland soils, and her hobbies include gardening, crochet, reading, and travel. Sounds amazing. So yeah, settle in. Each speaker is going to speak for about 30 minutes, and then after we have some quick, just a couple things to tell you guys about next month's event and some other little updates. So yeah, stick around and settle in for soils. Welcome, Kylie.
Welcome, Kylie.
Hi everyone. It's great to see how many people are interested in soil. Maybe you're more interested in beer, but that's okay too. My name is Kylie, and I'm actually from this sweet little town of Blue Lake. So I feel very honored to be able to come and speak to all of you in my hometown about, can you hear me? Okay. About something that connects all of us and connects all of life. Thank you. I want to start off by just the perspective I'm coming from. I didn't major in soil science in school. I just have a lot of extracurricular knowledge about soil. I'm really interested in it. I have this just undying curiosity about the soil. So I'm going to talk about from my experiences and learnings from working on various farms, doing a lot of research and reading, connecting with and collaborating with other local farmers, and tending lands myself. Next slide. Thanks. So, what is soil and why does it matter? I actually think that it's more of a convenience to consider soil as an it, because soil is actually many things. There are layers in soil that include clay, silt, and sand, water, and air, and an entire ecosystem of decomposed organic materials holding fungal networks that transport knowledge and nutrients throughout different layers, worms and beetles that help decomposition, bacteria, and more. It is said that within a single teaspoon of living soil, there are more organisms in there than humans on the planet. So soil is really complex. There's a lot of living beings interacting and communicating and connected in relationship, along with all of the nutrients needed to support life and growth. So there's a lot of drama going on underground, just like above ground. I think that soil and all the interactions going on within are beyond what can really fully be quantified scientifically or described in a presentation, but I will do my best to highlight some of the relationships that I've learned about and observed. So when I think about soil, which I do pretty often, I find that to me, soil really represents a space that holds death, decay, rebirth, life, and growth, and all of the connections existing in between. When there is death, the soil accepts that death and takes what that death has to give, passes it on to the next generation, so that it can go on to fueling more life, whatever that life might look like. Sorry. Okay. There are an immeasurable number of relationships that exist throughout this cyclical, ever-present process. I have one example here. We recently lost one of our hens to a wild predator out on our farm, which was really sad and emotional for us. But even though her life was lost, it made me really think about what her death gave. First of all, it gave nourishment to the animal that consumed her. And that animal surely went on to excrete part of its meal, and that was decomposed and reabsorbed back into the soil to provide more life. We were able to find some of our hen's remains, and we decided to bury her under a baby apple tree so that her body could be decomposed by microorganisms within the soil, releasing vital nutrients like phosphorus and calcium that can be fed to the tree's roots to foster its health and growth. One day, we will pick apples from that tree, and it just feels so special that we were able to take care of this hen for over 3 years, and she was also able to take care of us and provide eggs. And now it feels like that relationship hasn't really ended. It just looks a little different. So thinking about all of the relationships that must be formed below ground in order for that hen to go into growing a tree, or at least helping to provide nutrients to that tree, feels just so intentional and reciprocal. And I know that I, in turn, will compost the apple cores to make sure that they go back into the decay process and back into the soil for another generation of life, and this cycle just continues on. So soil also homes conversations. There are many conversations that are happening in the soil, some of which are between microorganisms and plants. There are many microorganisms within the topsoil, which is generally the top 6 to 8 inches of soil, depending on the setting. Above and within topsoil is where most of the decomposition is going on and where we plant our foods. Fungi and bacteria are able to stretch out their legs into their branching filaments and form a web into deeper layers of soil to extract minerals and nutrients and bring them back up to the rooted plants in the topsoil. And this leads me to one relationship that I'm really excited to briefly talk about here. There's probably a lot more that can be said. Next slide. Oh, that's okay. Thank you. Okay, so mycorrhizal fungi are, simply put, a type of fungi that form a symbiotic relationship with the root systems of growing plants in the soil. These fungi form networks throughout the soil that connect to the plant's root systems and to one another to exchange nutrients and information and water. These relationships allow for plants to receive nutrients and minerals that may not be nearby or accessible in the topsoil through the transportation services of the mycorrhizal fungi. So there's a plant without any mycorrhizal fungi relationship, and this is one with, so it increases the capacity. These fungi have, these fungi actually have enzymes that allow them to literally burrow deep into rocks, way deep under the soil, to extract minerals and then pump them back up to the plants to give them what they need to grow and be healthy. In this way, fungi help plants build their immune systems, promoting the creation of phytochemicals, which helps plants protect themselves against pests and diseases. There have been studies that actually show that when plants are attacked by a pest, they can send chemicals down into the soil, and the mycorrhizal fungi can produce compounds to help protect that plant from that pest, to repel it. And then plants being attacked by a pest or a disease can also communicate to other neighboring plants and warn them, hey, start planning to be attacked and start building up your immune system. They're coming. Okay, so Suzanne Simard, a scientist and author who I really love, has studied trees in the forest for most of her life, and found that these relationships allow for what she calls mother trees to share intergenerational knowledge with their kin, passing nutrients and wisdom to them via mycorrhizal connections in order to for their offspring to have the best chance of survival, supporting the health and resilience of generations to come. I think there's a lot to learn here about how trees and plants communicate, cooperate, compete, and find balance above ground and even above ground within healthy ecosystems. And this is a quote that I just really loved about reading her book, Finding the Mother Tree. When mother trees, the majestic hubs at the center of the forest, communication, protection, and sentience, die, they pass their wisdom to their kin, generation after generation, sharing the knowledge of what helps and what harms, who is a friend or a foe, and how to adapt and survive in an ever-changing landscape. It's what all parents do. Okay. Sorry, wasn't done with that page. Okay, I love this slide. So I'm going to go into it. But why do these mycorrhizal fungi stick around doing so much work? What's in it for them? When plants above ground photosynthesize, one of the outputs is in the form of liquid sugar that gets excreted from their root tips. These are called root exudates. So what you're looking at is a root tip with literal liquid sugar coming out of it in the soil. And this is what mycorrhizal fungi eat. So basically, the plants provide sugary snacks to the mycorrhizal fungi, and the fungi provide nutrients. They form a nutrient, I call it nutrient highway, and they bring up nutrients throughout the soil and other information to be returned. So they can live in a reciprocal relationship. This type of fungi also contains a carbon-based glycoprotein called glomalin, which is super sticky. It sticks to the outside of the mycorrhizal fungi's branching filaments and acts as a protection for them. And glomalin is like a glue. It helps kind of stick soil aggregates together. So that's what really helps to build the soil structure. So carbon being added to the soil, whether in root exudates, the liquid sugar, via photosynthesis, or from the plant's roots via decomposition of organic materials, really allows for these microbes to thrive and then produce more glomalin, which continues to build soil and store more carbon. This brief example is just a small glimpse of some of the relationships within living soil ecosystems, and there's still a lot we don't know. Okay, so in 2018, which I realized was a few years ago, National Geographic published a statistic that said that 75% of land on Earth has been degraded, which is kind of scary. Now, what does this mean? In my own words, degraded soil is that devoid of or lacking life and unable to function as a healthy, balanced ecosystem. I personally call degraded soil dirt, although I know that there are a lot of definitions for dirt. Within dirt, there's no collaboration or conversation. You won't find the same relationships as you would in living soil. Dirt won't contain much life. It'll lack structure without the fungi and the glomalin glue kind of sticking the soil aggregates together. It can sometimes appear dusty, but it might look different in different settings. One analogy that I heard was, so imagine soil as like an apartment building, and then that apartment building gets demolished. The dirt is like the rubble. There's not as much space for people to walk around and breathe in that space. The water storage and distribution has been broken, and the electrical and communication wiring is no longer connected. This is just an example of dirt, or some form of degraded soil. Okay, healthy living soil cycles nutrients, holds community, and is dynamic, similar to this nutty wheat bread. Nutty wheat bread has structure, all the nuts, it's kind of symbolizing all the living microorganisms, and it's porous. Dirt doesn't contain these same cycles and can often be loose and disconnected, lacking life and structure, similar to this pile of wheat flour. So this leads me to a demonstration. Y'all are kind of my guinea pigs. I learned this and I've been excited to show somebody, so here it goes. I learned this in Kiss the Ground soil advocacy course. So I'm going to show you all what it might look like to have rain fall down on living soil, which is the bread, and versus dirt, which is the wheat flour. And we can see like the differences between the two. And it is supposed to be muted. I'm going to talk about it afterwards. So it rained on the wheat flour, and it's raining on the wheat bread. So there's a lot of water around the flour and not very much water around the wheat bread. And the water around the flour is all cloudy, and it's dry in the middle of the flour. The wheat bread kind of absorbed most of the water. Okay, pouring it off the plate, you can see that the wheat flour water is all cloudy, full of flour. And there's a little bit of water coming off of the plate with the bread. Thumbs up. Okay. So, I hope that was exciting. So what happened here? I kind of was explaining it as it was going, but basically the wheat flour, as you could probably imagine, didn't absorb any of the water. The water, like the rainwater hit the surface and just ran right off. It didn't absorb. It also looked cloudy because it pulled some of the surface of the flour off with it. I poked my finger down into the pile of flour and it was bone dry. So if you can imagine like being planted in soil that's like that wheat flour, you wouldn't have very much access to water after a rain. And if you can imagine that the wheat flour is like sediment being pulled off, that's going to flow into local waterways, which is not good. The bread acted more like a sponge, so it has that glomalin holding it all together. It absorbed a lot of the water, but the water that did end up on the plate actually traveled through the bread and out the bottom. And that's similar to how healthy living soil absorbs rainwater or water and then helps to infiltrate it. It goes down and can replenish groundwater. Also, as water travels through the soil, it can be filtered as well. So that's why the water was so clean. I did stick my finger down into the bread and it was still wet, so if you were a plant growing in living soil or wheat bread, you'd probably be pretty happy and not so thirsty after a rain. Okay, so now that we, did I do that again? Getting ahead of myself. Okay, so So a lot of our food in the US, believe it or not, is actually growing out of degraded soils. In fact, 1/3 of farmable land in the US has been lost to land degradation in only the past 40 years. So they've become what's called desertified and unable to farm any longer. So you can't grow food out of it anymore. We're currently losing 4 tons of topsoil per acre per year on conventional farms due to farming practices that result in more erosion, more runoff, and further soil degradation. This is especially prevalent in the industrial agricultural spaces. So how did this happen, and what are some repercussions? Today, it is really common and a normal practice for farmers to till their cultivated spaces each year. Depending on the size of the space and the way that the farmer is tilling, this practice can be done using various tools and in different ways. Tilling helps farmers prepare their land to plant crops in when the spring comes. So it breaks up the soil surface, sometimes mixing in fertilizers and organic materials, and it helps control or remove weeds. But the issue with frequent heavy tilling is that it can rip apart those fungal threads that are living in that topsoil and break the soil structure apart. So it's kind of killing the biology in the soil. I recently read another interesting analogy. Change it. Imagine your home being hit by a tornado every year and trying to recover from that. This can be imagined what's happening to the life in the soil year after year. After so many years of going through this traumatic event, you might not be able to rebuild your home or community where it once was. I also need to note here, though, that all tilling practices are not the same. There might be different ways of tilling that might not have as negative effects. But I'm more talking about this like heavy mechanized annual tilling on farmlands. And it has been generally shown to be very impactful on soils. Unfortunately, though, when common tilling is frequently done to land, the soil becomes more and more depleted, losing biodiversity, life, as well as other nutrients and minerals. The topsoil being reduced to basically a layer of wheat flour. In order for a plant to grow out of degraded soil, nutrients must be outsourced and added to the land because there's nothing quite in it yet. Regardless of what nutrients are being added, the degraded soil will still be lacking those robust biological relationships that allow the plants to get more than just whatever's added. The relationships that provide the plants with minerals, helps them build their own phytochemicals, and other micronutrients won't exist in the soil or degraded soil. So now we have an overview of some of these sad issues regarding soil degradation on farmlands. But let's turn around and be a little more positive and talk about what can be done. What are some ways in which we can help soils rebuild ecosystem, particularly on lands in which food is being grown on? The regenerative agriculture movement has been gaining a lot of attention and momentum in recent years, which is focused on transitioning conventional farming practices that are degrading soils into a more holistic approach, incorporating practices that aim to heal the soil and restore health and ecosystem function to the land. Regenerative agriculture sets the relationships underground as a priority, knowing that they are linked to many other issues. So here are some core tenets of regenerative agriculture. Not everything's listed here, but I think these are the core ones. So context, understanding that no two farms are really the exact same, and so practices on one farm may be different on another farm. It's not like something that you could, it's not really a prescriptive set of practices that you can say, okay, all the farms do this. Least soil disturbance. So that may include reduced tilling or no-till. Keeping soils rooted. So planting cover crops when you're not cultivating a space. Keeping plants growing so that they can continue to feed the microorganisms that build the soil structure so that they're more resilient against erosion. Eliminating synthetic fertilizers. Those have also shown to have a negative effect on the biology.